Hello class, my name is Sarah Main and I'm going to be performing experiment 10, the calculation portion of the titration setup that we did from last class, or class before that, sorry. Okay, so I'm going to show you how to how to calculate the volume of the titration, the titration added. So to get the answer, we're going to take the final Biuret reading, which is 24. It was 24 milliliters. Minus the initial Biuret reading, which was 0 because it started at 0. And that gave us 24 milliliters. So for the moles now of sodium hydroxide, what we did was we took the volume of the titrant added, which was 24 milliliters, and converted it to liters. That gave us 0.024 liters and of the sodium hydroxide, and we multiplied it by, we set up our equation first, and we multiplied it by the moles of sodium hydroxide, which is, well, the molarity of it, which was 0.107, and then we divided it by the 1 liter of sodium hydroxide, and then the liters got canceled out, so what we got left was the moles of NaOH, of the sodium hydroxide, which was 0.003. Now for the moles of hydrochloric acid, what we took the liters of the titrant, which was 0.024 liters of the sodium hydroxide, and we multiplied it by 0.107 moles of sodium hydroxide divided by the 1 liter of sodium hydroxide. And then we also multiplied the one-to-one moles of hydrochloric acid and then sodium hydroxide. That's the equal number of moles at the stoichiometric equivalence point. And what we got was 0.003 moles of hydrochloric acid. Okay? And then to calculate the final molarity, or the concentration of it, we took, we already had everything in place, but I wrote out the equation again so you could see it fully. The 0.024 liters of sodium hydroxide times the moles of sodium hydroxide, which was 0.107 moles, and divided it over the 1 liter of sodium hydroxide. And then we multiplied it by the 1-to-1 mole ratio again of 1 mole of hydrochloric acid and divided by another 1 mole of sodium hydroxide. And then we multiplied it by 1 over, and then the 0.025 liters of hydrochloric acid is what we had from before. That was given to us. So basically for that one, we just did the moles of hydrochloric acid, which was the 0.003 moles that we did in the previous equation. And then we divided it by the volume of the hydrochloric acid, which is just the 25 milliliters. But when we convert it, remember we have to convert to liters, we converted it to 0.025 liters. And then when we divide those two numbers up, we get 0.12 molar of hydrochloric acid. And that's the final molarity or concentration of it. To get the average now, we had to add the three trials up and divide by 3. So to get these 3 numbers from the trial, this is the, once again, this is the molar of hydrochloric acid. We added each of them up, and say we did the trial 3 times, we just did 0.12 plus 0.12 plus 0.12, and we divided that by 3 and got 0.12 again. So really with the 0.12, when we added them all up together, it's supposed to be 0.36 divided by 3, and that's what's giving us 0.12 molars per liter. And that is all I have for you guys. This is the setup once again, and that's the calculation of the titration setup. Thank you. Have a good day.